This video is about a digital measurement technique, LIDAR, which stands for Light Detection and Arranging. What is LIDAR? It's a remote sensing technology. LIDAR technology uses the pulse from a laser to collect measurements. These are used to create 3D models and maps of objects and environments. About the history of LIDAR. LIDAR innovation has been around since the 1960s when laser scanners were mounted to planes. This sort of airborne LIDAR emits ground to supply distance estimations. LIDAR information headlight pillars towards the surface of got to be a valuable device for giving precise geospatial estimations within the late 1980s. So, how does it work? Scanner radiates the light waves, and then light waves bounce from the object and go back to LIDAR. LIDAR calculates the time spent on this way. LIDAR calculates the distance accordingly. Each of these pulse laser measurements processed into a 3D visualization known as a point cloud. Fields of usage. Mapping. Surveying tasks often require LIDAR systems to collect three-dimensional measurements. They can create a digital terrain, DTM, and digital elevation models, DMS, of specific landscape. Architecture. Laser scanning systems are popular for surveying the built environment. This covers buildings, road networks, and railways. Construction. LIDAR technology tracks building projects and produces digital twin for BMI applications. It can also help produce 3D models for the conditional monitoring of structures and Revit models for architects and structural engineers. And also in interior design. Laser scanners can be used indoors to measure space and create accurate floor plans.
And now, let's talk about LIDAR and architecture. We will start from the advantages. The first one is speed. LIDAR-based technologies work extremely fast on site. Dependent from the model and scale of the given object, it can scan it in a couple of minutes. So, it saves a lot of time. The second one is accuracy. LIDAR provides pretty accurate information regarding scale and measuring aspects. The third one is day conditions. LIDAR technology can be used day and night thanks to the active illumination sensor. It's not affected by light variations such as darkness and light, so this improves its efficiency. And the last one is low human need. LIDAR is able to complete wool work by itself without special human intents. All specialist has to do while working with LIDAR is just to check it from time to time. So, what about disadvantages? The first one is cost. LIDAR-based technologies cost a lot. Moreover, operating system costs extremely high too. The second disadvantage is after-work process. There is need on special softwares and specialists on the post-measuring stage. Several programs can deal with data processing and only special educated people can work with them. And the last one is amount of the data. Surprisingly, LIDAR collects too much information, so post-measuring process takes a lot of time and final documents are too heavy to work with. So, after taking all of these facts, what are the future predictions? Well, most probably new specialists will appear due to high demand for LIDAR machines, so every team will have LIDAR-focusing worker and person who will process the post-data. In addition, LIDAR creators claim that in the next few years, this innovation is going to be modified so it will be portative, and post-measuring process will be faster and easier to control. So, our conclusion is that even there are some cons in LIDAR system, amount of advantages is still prevailing. So, LIDAR is promising to be a leader in measuring technology in the closest future. Thanks for your attention.